Small-scale integration, SSI. The first integrated circuits contained only a few transistors. Early digital circuits containing tens of transistors provided a few logic gates, and early linear ICs such as the Plessey SL201 or the Philips TAA320 had as few as 2 transistors. The number of transistors in an integrated circuit has increased dramatically since then. The term large-scale integration, LSI, was first used by IBM scientist Rolf Landau when describing the theoretical concept Winking Sad Smiley 83. That term gave rise to the terms small-scale integration, SSI, medium-scale integration, MSI, very large-scale integration, VLSI, and ultra-large-scale integration, ULSI. The early integrated circuits were SSI. SSI circuits were crucial to early aerospace projects, and aerospace projects helped inspire development of technology. Both the Minuteman missile and Apollo program needed lightweight digital computers for the inertial guidance systems. Although the Apollo guidance computer led and motivated integrated circuit technology, 84, it was the Minuteman missile that forced it into mass production. The Minuteman missile program and various other United States Navy programs accounted for the total $4 million integrated circuit market in 1962, and by 1968, U.S. government spending on space and defense still accounted for 37% of the $312 million total production. The demand by the U.S. government supported the nascent integrated circuit market until costs fell in to allow IC firms to penetrate the industrial market and eventually the consumer market. The average price per integrated circuit dropped from $50 in 1962 to $2.33 in 1968. 85. Integrated circuits began to appear in consumer products by the turn of the 1970s decade. A typical application was FM inter-carrier sound processing in television receivers. The first application MOS chips were small-scale integration, SSI, chips. 86. Following Mohammed M. Attala's proposal of the MOS integrated circuit chip in 1960, 87, the earliest experimental MOS chip to be fabricated was a 16-transistor chip built by Fred Hyman and Stephen Hofstein at RCA in 1962. 29. The first practical application of MOS SSI chips was for NASA satellites. 86. Medium-scale integration, MSI. The next step in the development of integrated circuits introduced devices which contained hundreds of transistors on each chip, called medium-scale integration, MSI. MOSFET scaling technology made it possible to build high-density chips. 24. By 1964, MOS chips had reached higher transistor density and lower manufacturing costs than bipolar chips. 31. In 1964, Frank One Last demonstrated a single-chip 16-bit shift register he designed, with a then incredible 120 MOS transistors on a single chip. 86. 88. The same year, General Microelectronics introduced the first commercial MOS integrated circuit chip, consisting of 120 p-channel MOS transistors. 30. It was a 20-bit shift register, developed by Robert Norman, 29, and Frank One Last. 89. 90. MOS chips further increased in complexity at a rate predicted by Moore's law, leading to chips with hundreds of MOSFETs on a chip of late 1960s. 31. Large-scale integration, LSI. Further development, driven by the same MOSFET scaling technology and economic factors, led to large-scale integration, LSI, by the mid-1970s, with tens of thousands of transistors per chip. 91. The masks used to process and manufacture SSI, MSI and early LSI and VLSI devices, such as the microprocessors of the early 1970s, were mostly created by hand, often using rubylith tape or similar. 92. For large or complex ICs, such as memories or processors, this was often done by specially hired professionals in charge of circuit layout, placed under the supervision of a team of engineers, who will also, along with the circuit designers, inspect and verify the correctness and completeness of each mask. Integrated circuits such as 1K-bit RAMs, calculator chips, and the first microprocessors, that began to be manufactured in moderate quantities in the early 1970s, had under 4,000 transistors. True LSI circuits approaching 10,000 transistors began to be produced around 1974 for computer main memories and second-generation microprocessors. Very large-scale integration, VLSI. Upper interconnect layers on an Intel 80486DX2 microprocessor die. Very large-scale integration, VLSI, is a development started with hundreds of thousands of transistors in the early 1980s, and, as of 2016, transistor counts continue to grow beyond 10 billion transistors per chip. Multiple developments were required to achieve this increased density. Manufacturers moved to smaller MOSFET design rules and cleaner fabrication facilities. The path of process improvements was summarized by the International Technology Roadmap for Semiconductors, ITRS, which has since been succeeded by the International Roadmap for Devices and Systems, IRDS. Electronic design tools improved, making it practical to finish designs in a reasonable time. The more energy-efficient CMOS replaced NMOS and PMOS, avoiding a prohibitive increase in power consumption. The complexity and density of modern VLSI devices made it no longer feasible to check the masks or do the original design by hand. Instead, engineers use EDA tools to perform most functional verification work. 93. In 1986, 1 megabit random access memory, RAM, chips were introduced, containing more than 1 million transistors. Microprocessor chips passed the million transistor mark in 1989, and the billion transistor mark in 2005. 94. The trend continues largely unabated, with chips introduced in 2007 containing tens of billions of memory transistors. 95. ULSI, WSI, SOC and 3D IC. To reflect further growth of the complexity, the term ULSI, that stands for ultra-large-scale integration, was proposed for chips of more than 1 million transistors. 96. Wafer-scale integration, WSI, is a means of building very large integrated circuits that uses an entire silicon wafer to produce a single superchip. Through a combination of large size and reduced packaging, WSI could lead to dramatically reduced costs for some systems, notably massively parallel supercomputers. The name is taken from the term very large-scale integration, the current state of the art when WSI was being developed. 97. 98. A system on a chip, SoC or SoC, is an integrated circuit in which all the components needed for a computer or other system are included on a single chip. The design of such a device can be complex and costly, and whilst performance benefits can be had from integrating all needed components on one die, the cost of licensing and developing a one-die machine still outweigh having separate devices. With appropriate licensing, these drawbacks are offset by lower manufacturing and assembly costs and by a greatly reduced seed power budget. Because signals among the components are kept on die, much less power is required. See packaging. 99. Further, signal sources and destinations are physically closer on die, reducing the length of wiring and therefore latency, transmission power costs and waste heat from communication between modules on the same chip. This has led to an exploration of so-called network-on-chip, NOC, devices which apply system-on-chip design methodologies to digital communication networks as opposed to traditional bus architectures. A three-dimensional integrated circuit, 3DIC, has two or more layers of active electronic components that are integrated both vertically and horizontally into a single circuit. Communication between layers uses on-die signaling, so power consumption is much lower than in equivalent separate circuits. Judicious use of short vertical wires can substantially reduce overall wire length for faster operation. 100. Silicon labeling and graffiti. To allow identification during production, most silicon chips will have a serial number in one corner. It is also common to add the manufacturer's logo. Ever since ICs were created, some chip designers have used silicon surface area for surreptitious, non-functional images or words. These are sometimes referred to as chip art, silicon art, silicon graffiti or silicon doodling. ICs and IC families. The 555 timer IC. The operational amplifier. 7400 series integrated circuits. 4000 series integrated circuits. The CMOS counterpart to the 7400 series. See also 74HC00 series. Intel 4004, generally regarded as the first commercially available microprocessor, which led to the famous 8080 CPU and then the IBM PCs 8088, 80286, 486 etc. The MOS Technology 6502 and Zilog Z80 microprocessors, used in many home computers of the early 1980s. The Motorola 6800 series of computer-related chips, leading to the 68000 and 88000 series, used in some Apple computers and in the 1980s Commodore Amiga series. The LM series of analog integrated circuits. See also Icon. Electronics Portal. Icon. Physics Portal, Technology Portal, Telecommunication Portalicon. Engineering Portalimage. History of Science Portal, Companies Portalicon. Computer Programming Portal, Telephone Icon. Telephones Portal, Chokralski Method. Central Processing Unit. Chipset. Chips and Science Act. Integrated Injection Logic. Ion implantation. Microelectronics. Monolithic microwave integrated circuit. Multi-threshold CMOS. Silicon germanium. Sound chip. SPICE. Chip carrier. Dark silicon. Integrated passive devices. High temperature operating life. Thermal simulations for integrated circuits. Heat generation in integrated circuits. Notes.
Good. Let's start the video. It's a little bit late. It's 11. We have to stop. Go to bed. I will watch some YouTube. But that's a lot of length. I have to look this. But I have most of it. I have it on my paper. I have big pile of papers. But everything is a big mess. Because I made so new papers, all kind of version. I have to look at one day. I have to put all the pile of papers on a table. So, but this is why this video is called Looking at PC Gamer Hardware. Because I was to read about computer processors like this. I will do it again. But now I need to stop the video.